Hello, good day everyone. I hope you're doing well. A couple people
Hi.
missing, but we are just going to get started anyway. I like to start on time, so
Hmm.
we'll get going right away here. Um, so just a quick reminder, next Monday, so we only have class 2 days a week, by the way, so no class on Friday. And the other reminder is that next Monday, we're going to be meeting on campus. If that is an issue for you for health reasons or otherwise, I expect to hear from you. And we'll deal with things on a case-by-case basis. But otherwise, I'm going to be trying to record them. I haven't figured out how I'm going to do that yet. I have some ideas. I just got to basically go to campus and experiment. So that if you are not able to make it, if you do have to isolate or something, hopefully we have that option for you. Like I said, still working out the details there. So I think this past year has just been one step at a time for the most part. Okay, so last day we were talking about the water cycle. And so here's a little diagram showing some of the stages. And I had mentioned that basically, one thing to think about the water cycle, which are some things that we're going to be talking about a lot this semester, is of course that humans are intervening in the water cycle. We draw out water for various purposes, whether it's for our homes or agriculture or industry and various other things, and then we return it as well. And so you can see this diagram here is kind of showing a bunch of the things that we're doing to the water, but ultimately it does get returned to the environment eventually. And this is part of what we're going to learn about in this course, some of those uses and how we treat the water and what we're doing with it. So much more on that as we go along this semester. One of the biggest concerns, of course, is that what we are doing to the water can affect it, whether it's quality or quantity. So you can see this is trying to show here, there's two diagrams, right? The one on the left is a bit more of a, I guess you'd call it a balanced ecosystem where everything looks a little bit healthy and the water is abundant. If we use up too much water or if we pollute it too much, it can have effects, and those effects can be on human health, be on animal health, and all sorts of other things. So I was looking for some numbers. I like numbers and stats, by the way, so hopefully you'll enjoy them too. Water use in Canada. I was looking for more current data, but this seems to be the most current data I could find. Sometimes Stats Canada is a little bit slow, and they don't necessarily always publish and do research on every aspect of Canadian lives every year. But I imagine that the numbers are not going to be that different nowadays. You know, maybe a few percent different in each of these areas. So you can see that. By the way, I think. Wondering if I have, yeah, okay. So I think I'm just looking at these numbers here. This is, okay, this is millions of cubic meters, okay? So this would be 30 right here. This is the total amount of water used. So let me circle that here. Total amount of water used by Canadians. That's 37,892 million cubic meters. So that's basically 38 billion cubic meters. That's a big number. And I find this is really interesting how, you know, around here in particular, everyone's thinking, you know, Alberta and oil sands, of course, is a big user of water, and we'll talk about that in a minute. But this is for Canada, and you can see the biggest user of water is actually hydroelectrical plants. And they're mostly using that for cooling systems. I'll talk about that in a minute, but most people don't know that. That's actually the #1 biggest user of water in Canada. And same thing in the States as well. Very, very big use. Manufacturing is #2, and then households here you can see is #3. So probably no surprise there. You can see there's other uses, animals and crops, and I'll talk about those all in a minute. I think I have some kind of breakdowns in some of these things. This is Alberta, so I was able to find some data on Alberta as well. And you can see in Alberta, irrigation is actually the #1 use of water. So I know in Fort McMurray, we're not thinking about farms all the time, right? There's not exactly a lot of farmland up in northern Alberta. But if you go down to the Calgary region and that whole southern part of the province, there are a lot of farms. In fact, we have more irrigated farmland than all of the rest of Canada combined. And I have a number for you, I think, on maybe on one of these next slides as well. Oil and gas is on there, obviously. And cooling, this means thermoelectric cooling. So it's actually number 2. So here's a just a different representation of that. The one, this is for Canada, right? And you can see electrical power is about 68%, but it's the same numbers, I believe. So let's just talk a little bit about those uses, and we'll probably come back to some of those concepts and whatnot over the course. But one of them is, like I said, power generation, and this is mostly for cooling. And a very high percentage of this water is actually returned to the environment, and it's not contaminated by solutes or ions and whatnot. It's contaminated by heat. So it'll often be thermal pollution is the big issue. In my hometown, there's a hydroelectrical plant. It used to be coal powered. Nowadays it's using biofuels, and so it's an interesting story about how they've tried to green up the place and all that in Ontario. And you drive along the highway near the plant, it's a lot, the weather is a lot like here. It's very cold in the winter, you've got everything frozen, except for this one lake right near the generation plant, and that is actually where they dump the water. You're not allowed to do that kind of thing anymore. Nowadays they have to return it close to the ambient temperature, but this was sort of grandfathered in, and so they're still allowed to put their thermally polluted water into that lake. I imagine there's probably no fish growing in that lake. But it's interesting. You drive down the highway and you see that and you're like, whoa, okay, why is that not frozen? Just some other numbers for you there. You can see it's comparing the amount of water used in fossil fuels versus nuclear power generation. Nuclear power generation, as far as I know, we don't have any of that in Alberta. It uses a little bit more water because it does get hotter. And there are nuclear power plants in Ontario, and Ontario has the biggest population in Canada. So probably no surprise that it actually uses the most water and produces the most electricity. What about agriculture? I knew I had some numbers for you. Most of the water used in agriculture is irrigation, so about 85%. Some of it is used, of course, for our livestock. And you can see this note here, right? That is actually the #1 consumer of water, in that a small percentage of it is actually returned to the environment. And so that actually makes agriculture a pretty big consumer. And if you look at the data, I knew I had a number here for you. Alberta is about 60% of the irrigated cropland in Canada. It kind of blows my mind, but we do have a lot of farms in Alberta. We do have a lot of cows that we're feeding corn and whatever else to. So that actually makes up a lot of Canada's farmland. Plus, the southern part of Alberta is not as wet as the northern part, so we have to irrigate a bit more than some other places in the prairie provinces. Household use, we're going to talk about this more later on in the semester, but we're kind of going to think about it in 2 different groups. We're going to think of it as public use and 2 domestic use, right? So public, you can see, it just kind of means everywhere outside of your house. So the hospital, the schools, the shopping mall, even your workplace. Domestic means actually your home or apartment and the amount of water that you're using there, right? You can see there's some numbers there that for survival, we need about 5 liters a day. The minimum amount just for kind of other things is about 50 liters per day. And that's a very small amount of water. Most of us are using about 300 liters a day, right? And trying to use 50 liters a day is very, very hard to do. So how does Canada look when we're comparing to other countries? We consume a lot of water here. And I think I mentioned before, we have a lot of water, so it's cheap. And, we're maybe not as big consumers as the Americans, but, probably no surprise there. It seems that, the Americans, always seem to like to beat us in a lot of categories. There's just a higher consumption there per person. So the numbers here are about 1,300, 1,400 cubic meters per person. And that's for all uses, right? So that would include agriculture and electrical power and all those things. That equates to about 483 liters a day and 250 liters per person per day. So if you're wondering how much water you use, you can do a really easy test at home, right? You can put a bucket under your shower and collect the amount of water for 10 seconds. And then next time you take a shower, time your shower and see how long your shower was and how much water you just used in your shower alone, and you'll probably be quite surprised. So what does that look like? 250 liters. That's about, what do I have there? Looks like I have about 14 of those big jugs that you would see at Save-On or Safeway. So like I said, a lot of people aren't aware of how much they use. You know, if you keep track of it, it's very interesting. How many times do you flush the toilet a day? How many liters does your toilet use, and so on. It's kind of an interesting exercise in kind of awareness of consumption. So the other question is, how does Alberta compare? And it turns out in Alberta, we're in pretty good shape for water consumption. I'm not really sure what's going on in the territories or in Eastern Canada. It's kind of hard to tell what's going on in Eastern Canada, who the 189 is. They're obscuring exactly where it is. I don't know if the 189 is PEI or not.
That is actually PEI.
Yeah, so good job for PEI people. I'm not sure why they're doing so well. There's lots of reasons, why these numbers are all over the map.
It's probably because in Canada we're the smallest population,
Well,
like 150,000.
there's that, and you know what? A lot of the infrastructure in Alberta is newer, right? So if you look at the Eastern Canada, this was the first part of Canada settled. There's a lot of homes out there that are 150 years old, and they have toilets that are 40 years old.
PEI. They're all about. They've been all about green. Like I think compost are like 20 years ahead of Alberta.
Yeah,
Like
well, they're certainly ahead in some areas, but like I said, in
Mhm.
infrastructure, if you think about the fact that, in Fort McMurray, most homes were built in the last 30 years, so it's more likely we have more efficient toilets and plumbing and stuff for water consumption. But, perks of being newer and disadvantages, you're right, we're probably behind in some other areas like composting and waste disposal. Since we have lots of space compared to PEI, it's a pretty small province. You said you're from New Brunswick?
I'm from Prince Edward Island.
Oh, okay. I thought you said New Brunswick before. Okay, cool.
Yeah.
Yeah, I'd like to go out there. I've been to Nova Scotia. Um, so as I mentioned, here's just a comparison of water prices, and it's cheap here, right? So it makes it's very perfect sense, right? If something's cheap, we don't mind consuming a bit more of it. It's kind of like when gas prices go up, we're a little bit more frugal. When they go down, maybe you do longer road trips and those kind of things. You can see some of these countries here. I thought this was kind of interesting. I didn't realize water was so expensive in Germany, and I have no idea what's going on there in terms of, honestly, I know very little about Germany's geography and water resources. But obviously some places it's going to be more expensive. I thought that Israel was on this particular chart, and Israel is an interesting country because much of it is actually desert. So the water costs are from basically taking it from the ocean and removing the salt. And that's a very expensive process indeed. And I think Israel thought it was a little bit more than this actually than Germany, but I'd have to try to find that data. All right, a few more facts here. These are kind of older facts, but just something to think about. Water is an important part of our economy. And there are all sorts of businesses that are using water, either directly selling bottled water or using it for things like crops and farms. It's hard to estimate those numbers exactly, I would say, but these are some guesses from 2000. I found an article on this. And something else to think about is that, it's pretty common for municipalities to have some sort of issue with their water. Sometimes if you think about the last few years in Fort McMurray, we've had our water turned off and not accessible to consumers twice due to natural disasters, right? The flood and the fire. And you know, these things do happen all the time. And of course, it is a concern, right? So something we want to protect and take care of. So one thing that I was trying to look up some numbers for was water consumptions by the oil sands companies. And you can see the link I have there. This is from the Pembina Institute. I was using their numbers. There are a few other sources I was finding numbers, and this number of 2.5 cubic meters per 1 cubic meter of crude seemed to be about the average number people were quoting. I think the issue is that if you look at newer processes and in situ processes and those kind of things, the numbers do vary, and they're getting better at it as time goes on. So probably the more current numbers, they're actually using a little bit less water and all that. But again, you can see that here's some other numbers. That the oil and gas sector is about 7% of water use in Alberta, and in Fort McMurray, that's actually a pretty big percentage of the water allocated from a river, the Athabasca. So you know, that's an important thing going on. So I had some other numbers here for you. I was trying to figure out, and I'll show you the math here. So this is just one of my first math exercises. Starting next week, I want you to be bringing your calculator to class, because topic 2 is a little bit more math intense than all the other topics in this course. We're going to be doing some chemistry in topic 2, but thought I would just introduce a calculation today. And like I said, I was looking up and trying to find these numbers, and how much, my question was how much of the water of the Athabasca are the oil sands actually using. So I found these numbers here. And the numbers
Blaine?
are, yeah.
For the calculators, do you want us to like bring like just regular standard scientific calculators, or can we bring
Yeah.
like our graphing calculators too?
Either is fine. You know, it's just so that you can work on the problems in class as we do them, and I do them on the board, and sometimes it's good for people to help me, because you know, when I'm when I'm talking and writing, and sometimes my math gets a little sloppy, it's, you know, multitasking can be a little difficult. So it's good for people to punch the numbers in and double check my work.
So either model is fine?
Yeah, not a problem.
Okay.
So yeah, the question I had was how much water are we actually using? So I found these numbers here, right? We have 359 million cubic meters of water diverted annually. Apparently that's double what's used in the city of Calgary. And I found this other number about how much water flows down the Athabasca. So I found a whole bunch of different numbers on that. And of course, I found some numbers that talk about the spring where the flow is higher, and there's other parts where it's lower, but apparently this is the average one. And I found the number on Wikipedia, but they did give a link to another resource, which I forgot to link down there. But here's my math. And if you take a look at this, so what I'm going to do is I'm going to take 633, and that's cubic meters per second. And what I want to do is convert that to basically cubic meters per year. So it's not a very difficult calculation. You just have to kind of be patient and convert you know, seconds to minutes and to hours and so on until you get to years. So I'll show you how to do that. It's pretty simple. And the one thing that I always do when I do these kind of calculations is I always write in my units so that I can make sure that everything makes sense. So I don't know how to change my pen marker on this. Usually I put a different pen marker and I'll cross this out. You can see seconds cancel each other out. So if I multiply this by 60, that tells me how many I have per minute. And then we can convert minutes, of course, to hours. So yes, hours. So there are 60 minutes per hour. Okay, and then we convert that to days, 24 hours per day. And then, of course, 365 days per year. 365 days per year. Okay, so this is the number that I get. I punch this into my calculator, and I get approximately, I think it was 1.99, so I'm just going to round it up to 2.0 times 10 to the 10, and that's cubic meters per year. Okay, so one more calculation. So this is step 1. And step 2 is to figure out how much of that water is compared to the amount that's actually being diverted right? So we'll go like this. We'll go amount used over total amount, right? Like this. So sorry about my writing. It is neater, I swear. You'll see on the board it's a little neater. It's not so easy for me to write on the computer screen. It's just a little bit more awkward. So just let me know if you don't, you can't read a number very well. Okay, so 359 million. So remember, million is 10 to the 6. So that's basically like adding 6 zeros. And then the total water is, we just calculated that. So that's 2.0 times 10 to the 10.
It's 220 billion.
And I'm going to multiply that by 100% to get a percent. And I am getting 1.8%, assuming I did all my zeros and punched that in correctly. So is that a lot of water? I don't know. I was trying to find some data on this. I read somewhere they're allowed to use up to 3%, and I read somewhere else they're allowed to use 1%. So this is just a rough calculation. I'm not even sure if these numbers, this 359 or the 633, are actually up to date. But if you think about it, 1.8%, I mean, it's barely significant. If I went to the store and I bought $100 worth of groceries and they charged me an extra $1.18, I don't know if I would be too concerned. In the grand scheme of things, it is a lot of water. It's a very big river, but we're not really impacting it hugely in that particular regard. So just something interesting to think about. So I have a little video here for you. This is, I can't remember who put this video together. I believe it was the government, but I think it's in collaboration with the oil sands company. And they're just talking about water monitoring. And I think they do drop some numbers in there in terms of how much they're saying is used. And you'll see it's relatively comparable to what I just calculated. So I'll play this for you. I think it's pretty short. I think it's about 4 minutes or something like that. So here goes. 2.5 minutes.
I work for Alberta Environment, and the government of Alberta has a very extensive monitoring program in this region. We have 11 sites strategically located that continuously monitor contaminants in the Athabasca River and its tributaries. These ones here that you see collect a variety of different metals, from mercury to arsenic to the broad suite. One of the contaminants that's of primary concern are naphthenic acids, very specific to bitumen deposits and process-affected waters, and these are cutting-edge, leading-edge technology for identifying those concentrations in surface waters. And we get the full range through a day, through a week, through a month, through the entire year, what the pattern of natural contaminant loading is and any additional contaminant loading that may be occurring from industry. The mines are just right nearby here. Break this stuff off like this. This is what they're after when they mine. This is oil sand, and you can push your finger right into it, as I'm doing here. It is very soft, and it flows on a warm day into the river. And if you look over here, you can see the impacts of this natural loading. You can see the oil on top of the water from the river, basically in contact with the oil sands formation that comprises the banks of this river. The industry component of monitoring is a legal requirement as part of their approval conditions. And of course the companies have to take it very, very seriously, because being out of compliance carries very stiff penalties. Companies implement groundwater monitoring, surface water monitoring, and air monitoring, as well as other metrics used to describe impacts to the landscape. All of tailings ponds have some amount of seepage. That seepage is very slow and very low, however, it does occur. And so around those tailings ponds, we need to understand exactly what the seepages are and what those seepage rates are. And we have to make sure that the seepage collection systems that they put in are effective. If there were to be a spill or some kind of upset that put more naphthenic acids into the system, we would detect it on these and we would be able to determine that that had occurred. Fortunately, our results have shown that, that there have been no incidences in these systems, and that we're getting mostly background loading from natural sources.
The government of Alberta. So not a very long video there, but just kind of discussing that we are trying to do what we can, and I know there's lots of concerns about those tailings ponds at the oil sands companies and all that. And I'll be the first to say that the oil sands industry is not my area, and I'm consulting with Neil all the time. He has lots of interesting stuff, but I'm learning. And so I'll try to throw a little bit of Alberta and oil sands stuff in here and there, because I know it is relevant to all of us. But like I said, I'm learning myself, and this is I find it very interesting stuff, because that 1.8% I just calculated, and on the one hand, it looks like a very small number, but when you you see the scope of the oil sands and the size of their industry, it's huge, and we do and should be concerned about making sure that things are done right. So I'm going to switch gears and talk a little bit about Alberta's water, and this is a lot of this is based on that reading that I told you to check out. That will be on the first test. I don't have the date for the first test yet. I will be announcing that probably next week. So you don't need to worry about it. The test will not be next week. But it might be the week after, once I get a chance to kind of go over my notes and figure out where we're going to be by mid-January. So let's talk about Alberta water. We have not a huge amount of Canada's water, and about 2.2% of the fresh water in Canada. And partly that is because we don't have a lot of big lakes. If you look at some place like Ontario and Quebec, they have the Great Lakes. You look at Northwest Territories, there's Great Slave Lake. We do have a lot of rivers, and you can see that kind of number is that about 80% of the supply of Alberta's water is in the north. We have way more rivers and lakes and swamps and wetlands in northern Alberta, and about 80% of our people live in the south, and that's where 80% of the demand is, and never mind all that agriculture that's going on in southern Alberta. So that's something we have to deal with sometimes in Alberta. And they do talk about water scarcity in Calgary frequently. Some years are just worse or better than others. So here's some numbers I found from Alberta Environment. If you're interested in these numbers, I know anytime I see a billion, it's a big number. To me, it's just massive, right? But you can see it's estimating how much water is flowing into Alberta, how much is evaporating away, how much is falling on Alberta, and so on. And obviously there's going to be massive differences in some of the different geographical regions. That's one of the most amazing things I found about moving out to Alberta personally, is that it has so many geographical areas, right? We have the mountains, we have the prairies, we have the foothills, we have the boreal forest, we have the Badlands. Alberta is a really fascinating place to be. I guess this just kind of reiterates what I had said already, is that we have a lot of water in the north from rivers and lakes and wetlands, and a lot less in the south. Yeah, not much new information here. This is just talking about the different lakes and the different geographical regions, right? And so we live in the boreal forest, probably you know that, and we have a lot of wetlands in the boreal forest as well. And by wetlands, I'm referring to places like peat and muskeg, and swamps, and those kind of things, which contribute to our overall amount of water. We also have a lot of groundwater in Alberta. I feel like somewhere I found an estimate, but huge amounts of groundwater in Alberta. And so my understanding is you do talk about groundwater in Neil's class last semester. Is that correct?
Yes.
Yeah, so I don't know a lot about groundwater. one of my areas of deficit. I'm not going to talk about it a ton, but it is important in some parts of the world. Not so important in Alberta. I thought I had a number here. Let me just see. There's a number here, a few numbers actually. So you can see out of all our consumed water, it's a very small percentage. Why? Because we have lots of rivers. So when we're getting water, it's easy to get out of rivers and lakes. Much harder to access groundwater. You can see that other number there, 0.01% of our groundwater is apparently believed to be recoverable or accessible, right? You've probably learned, I think, let me just go back to that picture here, right? They're showing the groundwater here. And to be accessible, the groundwater usually has to be in some sort of aquifer. And so an aquifer is an area where the water is in the soil and saturated. And so sometimes we can't get at those aquifers, or they're just, they're just, the water's not found in a lot of quantity in one aquifer. I do have a number though that's not on this slide. And you probably know, if you're from a farm or a rural area, you probably have a well. And it is true that about 90% of rural Albertans, so that includes a lot of farmers and other people just living in the countryside, about 90% of them are using wells and some form of groundwater. I also found a number somewhere on the internet, is that apparently Alberta has about 200,000 active wells, and about 4,000 are being drilled a year. So I don't know if that's a big number or not, but it really is a small percentage of all of the water in Alberta that's used by humans. Although we have lots of it. So maybe someday, if things do get drier, you never know, we're always talking about climate change, whether that will be something that we're going to access a lot more. We live in the United States. Some areas of the States, it's the exact opposite. 80% of the water in some areas of California is all from groundwater. And at the moment, they're kind of trying to get through a drought, which means they have to drill their wells deeper and deeper and deeper. So I had mentioned aquifers. I like these pictures because they kind of show what's going on, right? And you can see, one word to know is water table, and the water table is right here. And that, of course, is where you are going from an unsaturated to a saturated zone of water. And so if you're making a well, you got to be drilling deep enough to get into the aquifer and past the water table. And probably a little bit deeper still, because of course that is going to fluctuate with the season. Probably a little bit more saturated early summer compared to late summer due to runoff and infiltration and things like that. Just another picture showing these aquifers, and some are, there's confined and unconfined, and can't remember what else I was going to say about this, something about the plants. But you can see the plants there are accessing the groundwater, of course. So let's talk about rivers, because rivers are a big deal in Alberta, particularly when we're looking at water and water sources. And I really like this diagram here. This is from Alberta Environment, and you can see they show the major rivers. So the Athabasca is, it's right up, where's the Athabasca? This is the Athabasca right here. So I'm just going to trace a pen. And you can see it's going all the way up here. And then, of course, that's Lake Athabasca up there at Fort Chipewyan. And the Clearwater is right here as well. So you can see it's pretty big, and that the green that they have around the river is trying to just kind of represent how much water we have for each of them. The Peace River is more water than the Athabasca, but you can see it's a huge supply of water. And if you think about this, it's starting way down there in the south, and it's starting in the Rockies and going through many, many communities along the way. So just looking at these units here, sometimes you see with water, people use cubic decameters. That's more of a sometimes thing. The common uses people will use is cubic meters, and then a big M liter, and that stands for megaliter. So that's a megaliter is 1,000,000 liters. And so when we talk about municipalities, often they talk about how many megaliters they're producing a day, because it's a massive amount, particularly if you think about a place like Fort McMurray, with a population of 80,000 or whatever it is, and we're all using let's say 400 liters a day or whatever, and so you got a very large amount. So one thing that we talk about rivers and the flow of water is we talk about watersheds. And you can see this is showing all the major watersheds in Alberta. And I have a little video here for you. If you don't know what a watershed is, it's very nice. It explains it. It's like 1 minute. So I'm going to play that right now.
What is a watershed? Is it a shed that holds water? Nah, try again. A watershed is all of the land that drains into the same location or body of water. People tend to think only of water bodies such as rivers, lakes and wetlands as being part of their watershed. However, any land, whether it is park, farm, forest, school parking lot, and even the soil we build our homes on is also included. Think of a watershed as a funnel, collecting all the water within a specific area and draining into the nearest body of water. Drop by drop, water is channeled into soil, groundwater, creeks and streams, making its way to larger rivers and eventually the ocean. Everyone in the world lives in a watershed. Watersheds know no political borders, whether local, national or international. Our environment, our economy and our society all depend on a healthy watershed.
So yeah, that's what a watershed is. So hopefully you've heard that term before. It's kind of all geographically, it's where all the water goes. And often you'll hear in environmental sciences people talk about watershed management. So they kind of mean all the water in a region, but it can be separated into different regions basically based on where the water flows. So sometimes you'll see the word as well, basin. So I think in that previous slide, I talked about the Athabasca Basin, and we'll come back to that slide in a moment here. I wanted to show you, you take a look at North America, and you can talk about major watersheds, and you can kind of zoom in geographically, right? So if you look at North America, for example, Canada has really 3 major watersheds, or 4, depending on how you want to classify it. Sometimes people will classify the Hudson's Bay water shed as a separate unity, but much of the water on the west goes to the Pacific Ocean. Central Canada, much of the water is going to the Arctic Ocean, and then of course eastern and southern Canada, Atlantic Ocean. If you kind of zoom in on Canada, we break these down and talk about different, sort of sub-watersheds within those, and you can see that I'll zoom in on Alberta in a moment. But if you take a look at Alberta, we've got water here kind of in the north going to the Arctic watershed, and that includes Fort McMurray. And you've got water over here going to the North Atlantic or Hudson's Bay. And there's a little bit of water in our south that goes to the Gulf of Mexico. I'm not exactly sure where that goes. I think it eventually ends up in the Mississippi and then the Gulf of Mexico. So that's where kind of our water goes. How do we figure out a watershed? I just kind of wanted to show you this, and this might be an exercise you do in something like Neil's class, but it's pretty simple. You may have seen these topographical maps, right? And these maps are showing the different elevations at different parts of the landscape, right? So you can see what this person has done here is they put these little X's at all the peaks. And so all over the map. And so of course, the water is going to follow gravity. And so what you can do is basically trace those peaks. And so the water here, for example, is going to go to the left. The water here is going to go to the right. And it looks like it's going to flow into this river here. It's looks like the Nelson River or something like that. And that's kind of an exercise. Like I said, we're not going to do that in this class, but just to give you an idea how these things are figured out. So just some other words, like I said, watershed, basin, sometimes you see catchment area or drainage area. All those are kind of terms used for watersheds. So back to Alberta, and we have all these major watersheds in Alberta. And we, of course, are in Fort McMurray, so that puts us in the Athabasca River watershed or the Athabasca River Basin. And so basically these ones here I have in bold all basically flow to the Arctic Ocean. So The Athabasca River, of course, eventually flows to Lake Athabasca, and that will flow north, and it connects with the Mackenzie River in Northwest Territories, and the Mackenzie River flows to Great Slave Lake, and that eventually flows north to the Arctic Ocean. Some of our rivers here, you can see the middle basins here. So these ones here, they flow east, and not exactly sure the geography there, but somehow they make it to Hudson's Bay eventually. And then in the very south part of Alberta, we have the Milk River Basin, which, like I said, I think it flows to the Mississippi. So I want to talk about the Athabasca River for a couple of minutes. As I showed you in these maps here before, it starts down here in the Rocky Mountains, and it starts in the Columbia ice fields. So some of you may have gone there. This is a really nice place to see if you're in Jasper or Banff. It's kind of halfway between Jasper and Banff, and you can go there. And this is the glacier there that's visible from. There's a little hotel and tourist stop kind of across the street. And you know, if you get lucky, you can go on one of these glacier tours. I've never actually done this. I've walked up to the glacier, but have not gone on the tours. I don't know if any of you have done it, but if you have, let me know if it's worth it or not. It certainly looks like a lot of fun. Wanted to show you a photo I took here. One year I went hiking on the other side. And this is one of these weird freaks of photography where I took some pictures, and most of them turned out just okay and in color. And for some reason, this one here, I hit the sun, and somehow my photo, it should have been in color, it turned out in black and white, and I thought it was a pretty cool photo. But you can see the glacier is basically right here, and it's melting. And I think I'm not exactly sure what I'm looking at, but I don't know if this is the parking lot there or not. It's a little hard to tell. It's mostly black, but pretty cool place to go. So the Athabasca River, or sorry, the Columbia ice fields are down here, and you know, they melt, and this leads to the beginning of the Athabasca River. The interesting thing about the Columbia ice fields, by the way, is they actually melt into different river systems. So over here, somewhere in that particular region, they melt into the North Saskatchewan River, which goes through Saskatchewan, and that empties out in the Hudson's Bay. And they also melt westward into the Columbia River, which eventually goes to the Pacific Ocean. So kind of interesting there. But you can see it goes through all these communities. So it goes through the town of Jasper and Hinton, a few other things in between. Doesn't quite hit Slave Lake, although a tributary does hit Slave Lake and High Prairie. And then you can see, of course, the town of Athabasca and Fort McMurray and Fort McKay, and ends up finishing at Fort Chipewyan, so which eventually drains into the Arctic Ocean. So very important river, fueling or giving water to all these communities, and a big part of the oil sands industries. So found some nice pictures. I like pictures of rivers and lakes. And, so here's some nice pictures of the river for you. I was looking for certain photos that look like Fort McMurray, so thought I would share these with you. And then a rainbow. Rainbows are always nice. That's a double rainbow if you haven't noticed. And then I think I took that one. Can't remember. Let's talk a little bit about water usage and licensing for a minute. Just looking at the clock, we're almost where I want to be, so in good shape here. If you take a look at the Athabasca River, as I mentioned, it's a high percentage of the amount of water used in this region is for the oil sands. So the number that was quoted by the Pembina Institute was 66%. And the second biggest use is other industries. And then I'm not sure what dewatering is, so I'd have to look that one up. But you can see municipal is in there. And
I can tell you what dewatering is.
Sure, what's dewatering?
Dewatering is when they pump all the water off of the areas that they're going to reclaim. So like,
oh, of course,
in the middle, yeah, like in the middle where out by Syncrude, where it's that big open area that they're reclaiming again.
Yeah.
They have to pull that out. So that's dewatering.
Right, okay, no, that totally makes sense. You know, I knew somewhere in the back of the recesses of my brain, it was in there.
They put the water there so that when the winds come up, it doesn't take all the sand away before they put the topsoil back on. So the
Okay,
water
that
there
makes
is
sense.
basically just there to hold it.
Yeah, okay. Yeah, no, that makes sense. Cool, thank you very much. So what about our regional municipality? Of course, there's Fort McMurray, and we get our water from the Athabasca River. And same thing with Anzac. There are other communities, of course, in the regional municipality, and you can see them on this map here. So we've got Fort McMurray is where's Fort McMurray? Oh, it's down there. Sorry, I was looking too high. But we also have Anzac and Joinville and Conklin, and they get them from the Christina River Lake system. And Fort Chipewyan, I don't know why I have it written on there twice, but they get it from Lake Athabasca. So Fort McMurray, the very first thing I learned about Fort McMurray before moving here was that it has 5 rivers. So I was like, okay, what are they talking about? That's crazy. But here's the map, and you can actually see them quite clearly. We've got the Athabasca, so that's the big one. Depending on where you live, you might be familiar with the Horse River, kind of goes in there behind Abasand, and there's some nice trails that you can hike down to it. If you live in Grayling Terrace, you might be more familiar with the Hainstone. The other big one is the Clearwater, and then there's the Snye. And I think somebody pointed out to me once there's another river somewhere. I can't remember what they were talking about now. But those are the obvious ones anyway. I wanted to point out a couple of other things here. We do have 2 water treatment plants in town. One is the drinking water plant, and that's what you see basically when you're driving over the big bridge. And it's if you're driving north, it's on the left side of the bridge. And there's actually a lot of other municipal services there, but that's where they treat the water that goes to our taps. And the other plant we have is the wastewater plant. It's not quite as visible from the highway. You can see it from the highway. It's a big blue building that you would see basically when you go to the underpass that goes to Timberley, and if you're on that overpass, it's kind of just right there off the highway, and it's on the river. So we'll talk more about those later. Question?
So our wastewater treatment plant is upstream from our drinking water plant?
No, that's downstream. That's downstream. Our river flows north. And that's why we had so much trouble this year.
Oh, I read it the other way around. Okay,
Yeah.
so
And that's why we had so much trouble this year with the flooding, because, well, our rivers flow north, so it's more likely to be frozen up north. And there was, 25 kilometers of ice blockage that, and the Clearwater was ready to flow, unfortunately. So a couple other things for today. One thing that you may hear about in some of your other classes is sometimes they talk about Alberta green and white zones. And this has a lot to do with various types of resource management, including water. The green zones are often considered to be like public, and the white zones are more private. I kind of have a little chart here I made in terms of, and there's different rules and legislations around the management. So you can see, if you look on the left there, the green zones are a big percentage of Alberta. And much of it is crown land, and much of it is boreal forest and muskeg. But there's still uses. We have forestry, oil companies, etc., that are using it, and much of the regulation for its use is coming from the provincial governments. These zones here, by the way, these are the national parks, and they're kind of a third category because they're under federal jurisdiction. The white zones are the private, so that includes towns and cities and those kind of things, and a lot of the usage and regulation is also governed by municipal governments. So if you see that kind of language, that's what it's talking about. Green basically means crown land, and white means private and settled. So last slide for today, actually, let me just take a peek here, yes. Last slide for today is who is responsible for our water. So we have a Water Act in Alberta, and that's under the government of Alberta. And so the government issues water licenses, and so they do regulate it at their level, and that includes how much can be withdrawn, from where, how fast, and exactly how it must be returned to the source. And so that's what these water licenses would include, right? In terms of, and that's something we're going to talk about when we talk about wastewater treatment. You can't just dump stuff in the river. You have to treat it, and there's regulations about how much salts it can have in there, how much ammonia, all those kind of things. And so they issue the water license to smaller entities, and that includes towns and cities, and of course industries as well. So I'm just going to say the second part of this lecture notes is about water properties, and this actually folds really well into our next unit, which is water chemistry. So we're going to get into a little bit of chemistry soon. So like I said, bring your calculators, and we're going to do lots of problems starting next week. So I guess I will see you in class on Monday, and hopefully you have a wonderful weekend, and we'll see you then.
Thank you.
You're welcome.
Thanks.